All right, today we are working on section 1.6, which is calculate the limits using the limit laws. This section is very important. Questions like this would be on the coming exam and very likely on the final as well. So please make every effort to learn how do we calculate limits algebraically. All right, so number one, we're gonna evaluate the limits. In practice, to calculate the limit, at a point, what we're gonna do first, we're gonna take the number and substitute to the function. And so if you have limit at 2, we take that 2, substitute to the function. And then we can get 3 cases. Number one, we can get a number. If we get a number, that means the limit is that number and we are done. And this is the example. So if you have a limit, if we have a limit as x goes to 2, 3 times 2, always we start with taking the number and substituting this. So we're gonna have 3 times 2 plus 1, and in that case, 6 plus 1 is 7. So the limit as x approaches 2 of this function is 7. We got the number, we are done. This is the case that the limit is the value of the function. Last time we talked about that. Now, here's another example. So we can put as A and example B. The same here. First, always we take and substitute. So in that case, we're gonna have sine pi over 2. And sine pi over 2 is, if I look at the sine curve, here's 2 pi. This is pi. So this y is pi over 2. So from the graph, we can see clearly that sine pi over 2 is 1. So the limit as x approaches pi over 2, sine x is equal to 1. So this is the first case that we can get. I'm separating this. First case, we take the number and, we always take the number, substitute, and see what's happened. First, we get the number and the limit is done. Number 2, maybe I will wait until you take the first notes. Take a minute, and then we will move on to the second part. All right, case 2, you can get an undefined term, for example, 0 over 0. 0 over 0 is undefined. Then what we need to do, we need to change the form, reduce the fraction, or perform whatever calculation is, and start from the beginning. So this is the case. I have limit as x goes to 1, x minus 1, x squared minus 1. If I take, so usually to keep some kind of proper notation, we would do like this. Since at the beginning, I don't know what I'm getting, I take this substitute. So this would be my on-site calculations, 1 minus 1 over 1 squared minus 1. And I'm getting 0 over 0. And I put in like those lines to show that this is my online calculation. So if I get the number, I'm done. If I don't get the number, I need to do something. So in that case, we will factor the bottom and try to reduce it. How can we factor the bottom? So this would be equal limit as x goes to 1, top stays x minus 1. How can we factor the bottom?
X minus 1, x plus 1.
Excellent. X minus 1 and then x plus 1. Very good. We are using the formula that a squared minus b squared is equal to a minus b, a plus b, or simple quadratic factorization, looking for two numbers when their multiply is -1, when you add them is 0, right? So then we can reduce it. We can reduce the factors. So we reduce x minus 1, x minus 1. And we are left with limit as x goes to 1, 1 over x plus 1. Once I perform something, I start from the beginning. So beginning is that you take the number and substitute for x. So in that case, I'm getting 1 over 1 plus 1 is 2. So the limit is 2. Questions? Okay, are we ready to move on?
I have one question.
Go for it.
So, let's see. So it's going to be 1, or when you factor it out, it's x minus 1.
And the second case, what we can get is some number over 0. In that case, the limit would be plus or minus infinity, and we do need to consider left side limit and right side limit. For example, 1 over x or one of those ones. Go ahead, take the notes, and we will solve those problems. Okay, are we ready to go? So I start the starting limits, I always start the same way as before. I take the number and substitute, and I'm getting 1 over 0. If I get 1 over 0, I'm sorry, 1 over 0, you can indicate this in the curly bracket. Not necessary in this case because you can see it, so it's not needed. So in that case, I do need to consider left side limit and right side limit. So limit as x goes to 0 from the left, 1 over x, and we know that it would be infinity. I only need to figure out whether it's plus infinity or minus infinity, because we already know by the definition that it's always would be infinity. Number over 0 in terms of limits, it's always infinity. And also limit as x goes to 0 from the right side, 1 over x. And I also know that it's gonna be infinity. I only need to figure out whether it's plus or minus infinity. And to do it, there are several ways. In this case, we know the graph because it's a simple graph, but that's not always gonna be the case. So I propose that we choose a number and see what is the value of the function, positive or negative. So if I have a 0, I need to choose a number very close to 0, but on the left side. In that case, it does not need to be very close because we're not looking for exact approximation. So any number on the left side of the 0, if I take -1, for example, or -1/2, I substitute -1, I'm getting 1 over -1, which is minus. So that's how I determined that the infinity is negative infinity from the left side. Question? And the same story I'm doing from the right side. So if I approach 0 from the right side, I can choose 1. If I choose 1, 1 over 1 is positive, so that's the value is positive. So to determine whether it's plus or minus infinity, you choose the number that is from the left side of the 0 or from the right side of the 0. So two things going on right here. One is piece of knowledge that you know that if you get number over 0, the limit is always infinity. Only you need to determine whether it's positive or negative infinity. To determine that, you choose a numbers from the left or right. And this should also match with the graph. We know the graph of the 1 over x. It's a straightforward graph. It's like this, right? This is 1 over x. So if I approach from the right side, I see that the limit goes to infinity. So my answer is correct. If I go to the 0 from the left side, I see that the limit goes, the function goes to negative infinity. So I am good. Questions? In similar way, we're gonna solve this limit as x goes to 0, 1 over x. So first, I always substitute 1 over 0 square. So I'm getting, Yes,
I do have one question, sorry.
yes.
For the last question, would it be, it doesn't exist because?
So if you want to limit at this one, yes, you can say that the limit at 0 does not exist because left side limit is not the same as right side limit. Correct.
Okay, thanks.
Correct. You can say that this does not exist, the limit at 1, yes. But to justify why it does not exist, this would be the justification. So on the exam, it's not sufficient to say that the limit does not exist. If this question on the exam has, for example, 6 points, you will get 1 point for stating does not exist. Justification and showing your work gives you another points. Okay, so we're moving on. So this one is, of course, 1/0. So 1/0, we need to consider left side limit and right side limit. X goes to 0 from the left, 1/x squared. And we know that it's either positive or negative infinity. And limit as x goes to 0 from the right, 1/x squared. We also know that it's either positive or negative infinity. So now I'm choosing a number. Here's my 0. I'm choosing a number from the left of 0. So from the left, -1 or -1/2. So I would have 1/-1 squared if I substitute -1. -1 squared is positive, so this value is positive. That's why I have positive. Questions? If I choose a number from the right side, for example, 1, and I substitute to the function, so this is 1/1 squared. 1 squared, the value is also positive. So the limit is positive infinity. So yes, if somebody was concluding this limit is positive infinity or simply infinity. And we also know the graph. This is simple function. 1/x squared has a graph like this. Y equal 1/x squared. All the calculation we are doing does needs to match with the graphs and everything we are learning or learned before. So if we approach this function 0 from the left side, we see that the function goes to infinity. And from the right side, if I approach 0 from the right side, I can see that the function goes to infinity as well. So limit is infinity. Questions? No questions, so we're moving on. All right, so this is all 3 cases that we have. Always take numbers, substitute. You can get a number, we are done. You can get 0/0, undefined term, that means reduce, do something, keep going. And the 3rd case is you can get number over 0. In that case, the limit would always be either positive or negative infinity. And now we're gonna solve a whole bunch of problems to get good in limits. Those types of problems will be on the exam and very likely on the final as well. I wrote it down all of them here, but I'm gonna separate them one by one. So pretty much question says, find the limit. Go ahead, write the limit down and we will keep solving it. All right, I think we are ready to go. So first thing, we always take this number and substitute to the x. So I'm gonna have 1 minus cube root of 27 times 27 minus 20. And let's try to figure out if that exists. So cube root of 27 is what?
3.
Correct. So we have 1 minus 3 times 27 minus 20 is 7. 1 minus 3 is -2 times 7. The final answer is -14. the limit exists and we got the value, that means we are done. The limit exists and the value is negative 14. Questions? Okay, moving on. Example B, please write down the example. We have limit as x goes to 2 of x squared plus x minus 6 divided by x minus 2. So I'm gonna first substitute. So I'm substituting 2, so I have 2 squared plus 2 minus 6 over 2 minus 2. So we have 4 plus 6, 6 minus 6, 0 over 0. So this is the case that I have 0 over 0. That means we need to do something, reduce or do something, change the form. So in that case, we will factor this. So we have limit as x goes to 2. How can we factor the top?
X plus 3, x minus 2.
Perfect. X plus 3, x minus 2, quadratic factorization, right? On the bottom, we keep x minus 2. I put it in parentheses. Now we can clearly see that we can reduce this. And we are left with, I didn't perform the limit yet, so I copied the limit. Limit as x goes to 2, and I'm left with only x plus 3. Now I'm performing the limit, so I take this 2 substitute, so it's 2 plus 3 is equal to 5. Points on the homework and on the exams are given for showing the steps. They are not given only for answer. Answer gives you 1 out of 5, 6, 10 points, whatever it is. Make sure you show the steps that you have understanding what we are doing. Questions?
Yeah, I
Yes,
have a
I
question.
do have. Go ahead.
Okay, so you always have.
Example C, we have t approaches 4, and we have 4 minus t over 2 minus square root of t. I start always by substituting the number and see what's happened. So we have 4 minus 4, I substitute for t, over 2 minus square root of 4. 4 minus 4 is 0. Now I have 2 minus 2 is 0. I'm getting the symbol 0 over 0. If you don't get 0 over 0, then you have different case. So in that case, we do need to reduce or do something. So we have limit as t goes to 4, 4 minus t over 2 minus square root of t. And in that case, we're gonna do multiply by conjugate. Conjugate is the term that is with plus. If you have minus, it's gonna be with plus. So in that case, we're gonna multiply on the bottom 2 plus square root of t. Whatever I do on the bottom, I need to have on the top. 2 plus square root of t. You cannot multiply by different terms, otherwise you're changing the value of the original stuff. The purpose of doing it is to eliminate 0 from the bottom, or 0 from the square root. This could be also done different way as well. All right, so in that case, I'm gonna, on the bottom, apply the formula that we've been talking. It's a minus b times a plus b, which is a squared minus b squared. That's a shortcut than just multiplying out. If you don't know or don't remember this formula, you can simply FOIL it, multiply out, and the middle terms should cancel out as well. So what we have is equal limit as t goes to 4. Probably on the top, I'm not doing anything yet because I don't know what's gonna happen. I need to cancel and reduce something. So if I start multiplying out, then I would need to cancel, factor out back. So I'm not doing anything on the top. On the bottom, this is my A. If we follow the formula, this is A minus B times A plus B. So the formula says A squared, square the first term. So 2 squared is 4. Formula says minus. And then we have square root of t squared, which is t. So we see that we are getting the same number, the same factor, right? So in that case, 4 minus t reduces out. So we have equal limit as t goes to 4. And I am left with 2 plus square root of t. Once you reduce it, you start over. So you take the number, substitute, and see what's happened. Once you substitute the number, that means you're performing the limit. So we have 2 plus square root of 4, which is 2 plus 2, or in other words, 4. Questions? Those type of questions you can expect on the exam, on the coming exam 1, and also on the final. This is the essence of the limits.
On the exam, do you want the most simplified answer like 4, or would you take like 2 plus 2?
No, it does need to be simplified to the end. 4, yes.
Okay.
Moving on, example D. We have limit as x goes to 1, 2 plus x over x minus 1. I always start with substituting the number for x. 2 plus 1, 1 minus 1. I'm getting 3 over 0. What does that mean in terms of limit?
It goes to infinity.
Very good, equals to infinity. So we do need to consider left side limit, limit as x goes to 1 from the left. Copy the function 2 plus x, x minus 1 equals. And we do know it's infinity. We only need to figure out whether it's positive or negative infinity. And then we also consider limit as x goes to 1 from the right side, 2 plus x over x minus 1, which also gonna be infinity, but we do need to figure out whether it's positive or negative infinity. So to figure this out, we take a number and substitute. Look at the number line, 0, and we have 1. We need to take a number from the left side of 1. Left side of 1, it can be half, or it can be positive 0 as well, right? So I choose a 0, so we're gonna have 2. I'm substituting to the function, or this function doesn't matter. 2 plus 0 over 0 minus 1. And I really don't care about the value, but I care whether it's positive or negative. 2 over negative 1, I'm gonna have 2 over negative 1. I know that it's negative. So this negative gives me the minus for the infinity. It's minus infinity. That's how I determine that. Now I need to do the same for number from the right side and a number from the right side of 1. We can take 2 or 1/2. So if I take 2, I'm gonna have 2 plus 2 over 2 minus 1. which is 4 over 1, it's plus. So that gives me the plus for the infinity. So we can state that this limit does not exist because left side limit is not the same as right side limit. Questions?
Could you go over the positive limit again? How come it's positive and not negative?
So you choose a number from the right side. You choose a number from the right side of 1. Number from the right side of 1 as you approach 1 to 1. So I'm choosing 2. Any number would do it. If I choose number 2, I substitute 2 to the equation. So 2 plus 2 is 4. 2 minus 1 is 1. So I have 4 over 1, which is plus. I should have wrote plus. It should be equal plus. I already have a mess.
Okay, thank you.
Other questions? Moving on to the next limit. Limit as x goes to -4, we have 1 over 4 plus 1 over x, and then over 4 plus x. I always start with substituting number -4 and see what's happened. 1 4 plus 1 over -4. 4 plus -4. 1 4 minus 1 4 is 0. 4 plus -4 is 0. I got it 0 over 0. If you have 0 over 0, that means we need to do something, reduce the fraction or do something. Limit as x goes to -4. 1 over 4, I'm rewriting this, plus 1 over x over 4 plus x. I'm gonna find common denominator on the top. So 4 and x would be 4x. This needs to be times x times x. This one times 4 times 4. I'm performing the fraction first. So we have still limit as x goes to -4. And on the top we have x plus 4 over 4x all over 4 plus x. 4 plus x is 4 plus x over 1. To divide by a fraction means multiply times its reciprocal. So I'm performing the, so we have limit as x goes to -4, x plus 4 over 4x times multiplying times its reciprocal, which is this part, 1 over 4 plus x. We know 4 plus x is the same as x plus 4. So those two can reduce. So we have limit as x approaches -4, 1 over 4x. After you reduce, you start over. Take the number, substitute to the equation. So since I'm substituting, I'm performing the limit, no more limit sign. So we have 1 over 4 times -4. The limit is 1 over -16. This is the final answer. Questions?
I have a question.
Go for it.
on like the exam or even on our homework, if we don't put the limit x minus 4, would we get docked points for that?
Yes, theoretically, yes, that's mathematical error. It's a small
Okay.
error, but it is a mathematical error, yes.
Thank you.
I cannot give full points unless it's fully correct. So I would subtract a point or half a point, yes. Other questions?
Earlier in the equation, when you times it by x and then times it by 4, why did you do that again?
To perform this, to add this fraction. How do we add the fraction? We would like to add the fractions. I would like to make one fraction here. So to make one fraction, how do we add fraction? We get common denominator and then add the tops, right?
Yeah, that's right. Okay. Cross multiply.
Theoretically, it's not cross multiply, but I see you could think like this, yes. Other questions? Moving on to the next example. We have limit as x goes to -1, x plus 2 over x minus 3. We always start with substituting -1 plus 2 over -1 minus 3. Because if we get lucky like this time, we are done. So this is 1 over -4. So the answer is -1/4. Questions? Yes.
So does it matter if we put the negative sign in front of it or if we just leave it in the denominator?
Those are two correct answers. You can leave it like this, that's correct.
Thank you.
It's all equivalent, yes.
Would it matter if we did a decimal or a fraction for the answer?
So it does matter. Oh, hang on, I'm moving to the next one. So yes and no, that depends. I will explain you right away. So if the fraction is 1/4, you have terminated decimal 0.25, it's correct. If the fraction is 1/3 and you write 0.33, that's not exact value because 1/3 is 33 or 66. I don't remember how is it, 3333 probably, something like this. So depends. If this decimal is terminated, yes, it's correct. Both are gives you full points, but in this case, not exact. So that depends on the fraction. All right, in that case, I'm taking 0 substitute. So I have square root of 4 plus 0 minus 2 over 0. Square root of 4 is 2, minus 2 is 0 over 0. So we do need to change the form, do something. So we have limit as x goes to 0, square root of 4 plus x minus 2. I'm rewriting what I have. So we try to eliminate at least one of those zeros, and by doing so usually when you have fraction, we multiply by the conjugate. Conjugate means exactly the same with the plus in this spot. So I'm gonna multiply this. Multiply this times square root 4 plus x plus 2. Whatever I do on the top, I need to have on the bottom. 4 plus x plus 2. So this is, call it conjugate of the plus and minus. The purpose of doing is to employ the formula or just multiply this out. So if we go this is my first parenthesis, this would be my a minus b times a plus b. And we know a minus b times a plus b is a squared minus b squared. or just multiply this out. So we have limit as x goes to infinity. I'm sorry, to 0. First term square. So we would have square root of 4 plus x and square it. Square root and square cancel out, so I'm only left with 4 plus x. So that's on the top, 4 plus x. Minus second term square it. So you can rewrite this one if you wanna. This would be the step in between. Maybe I should have written it down here. So that would be first term square it minus 2 square it over x times and whatever we have. 4 plus x plus 2. So we have limit as x goes to 0. First time square root is 4 plus x minus 2. I'm sorry, minus 4 over, usually don't touch and hope that something gonna cancel out. Square root 4 plus x plus 2. So 4 and minus 4 cancel out. So I'm left with x only, so that x gonna reduce with the bottom x. So we can either rewrite, we should have actually rewrite to have proper notation. Limit as x goes to 0, I'm left with x over x, square root of 4 plus x plus 2. Now I can reduce the x's. So I am left with limit as x goes to 0, 1 over square root of 4 plus x plus 2 equals limit. Oh, I'm sorry, we're performing the limit already. So we have 1 over square root of 4 plus 0 plus 2. Square root of 4 is 2 plus 2. 1 over 2 plus 2, which is 1/4. Questions? No questions. Moving on. Do we have more examples? All right. One more example. Limit as x goes to -2 of 2x over x plus 2. Substitute the number first. 2 times -2 over -2 plus 2. So we have -4 over 0. -4 over 0, we know the limit will be infinity. We consider the positive left side or right side limit. -2 from the left. If you don't want to keep writing the formula, you can write f of x, but don't leave limits by itself. That's a mathematical error. X plus 2. And we know that the limit would be infinity up to the number, right? Positive or negative infinity. X goes to -2, 2x over x plus 2 equals, we also know the limit will be infinity. So to decide whether it's positive or negative infinity, choose a number. We have 0, -1, -2. From the left side to 2, the number could be -3, right? So if I take -3 substitute, we have 2 times -3 over 2, I'm sorry, -3 plus 2. Negative 3 plus 2. So it's negative 6 over negative 1. The value is positive. So this positive value is going to give me positive infinity. Now I'm choosing from the right side number, going to negative 2 from the right side. Going to negative 2 from the right side, it can be negative 1. So we have 2 times negative 1 over negative 1 plus 2. So this is negative 2 over 1. This is negative value. So this negative value gives me the minus to the infinity. Questions? And if we want, of course, we can say that this limit does not exist because left side limit is not exactly the same as right side limit. Please make sure you practice with those ones. Next, we have limits laws that we will discuss.